Problem number 5 is asking us to find the power series representation and the radius of convergence of the given power series. So in this case, they actually give us two different functions. So what that means is we're going to have to find two different power series in this case. So we'll start with the first one. Starting with the first one, all of these look like they're in the form of 1 over 1 minus x, but some of them might require a little bit of factoring or manipulation to actually get there. So by focusing on this first one, if I pull out a 7 and I pull out an 8 from the bottom, I actually end up with 1 over 1 minus x over 8. Okay, cool. So I can find a power series from that. So 1 over 1 minus x over 8, that becomes the power series, 7 over 8, summation n equals 0 to infinity of x to the n divided by 8 to the n. Cool, okay. Now if we focus on this next one, I notice immediately that the x is in the wrong position, so what I'm going to do is I'm actually going to flip it. So when I flip it, I actually end up getting negative 9 plus x. And all I did was, again, I just reversed the order. So same thing down here, I'm going to pull out an 8, and I'm also going to pull out a negative 9 here. Now what I end up with is I end up with 1 over 1 minus x over 9. Great. And there's also still a plus sign in between, and this negative is still existing here, but I'm not going to factor it in because we don't want to worry about constants too much in this case. We're really only looking for radius of convergence. So if I go ahead and make a power series out of this, I end up with 8 over 9 summation n equals 0 to infinity of x to the n divided by 9 to the n. Okay, great. So now I have my power series representation for both of them, but what I need to do is I need to find a radius of convergence. Now, when we have two series multiplied together, we want to find the radius of convergence that satisfies both of them at the same time. So these should have two different radius of convergence because, well, they're two different power series. So let's go ahead and find the radius of convergence of both of them and see which one satisfies both of them. So if I find the radius of convergence here, these are just geometric series. So if you remember, the formula for a geometric series says that if I have x to the n, summation n equals 0 to infinity, as long as the absolute value of x is less than 1, this series is convergent. So if I have x over 8 to the n, I can raise that, or put that into absolute value bars, and what that tells me is that my radius of convergence has to be less than 8 in this case, or my x value has to be less than 8, so my radius of convergence is 8. Same thing here, I have x over 9 to the n, so if I turn that in between absolute value bars, I end up with x, absolute value, is less than 9. So I found the radius of convergence of both of these series, but again, I need to find a radius that satisfies both of them at the same time. So I have one that says x has to be less than 8 and one that says x has to be less than 9. Well, already what stands out to me as a red flag is that this one is a little bit less than this one. If this is less than 9, if I plug in 8.1 as my x value, it will satisfy this, but it won't satisfy this. Consequently, if I plug in 7.6, I'll satisfy this equation, but I'll also satisfy this equation. So when I'm struck with the problem of picking a radius of convergence, I always want to pick the smaller one. The smaller one encompasses all the points in this series, and it encompasses most of the points in this series, but the most important thing is that no x value in this radius of convergence will make this divergent. So because of that, my radius of convergence in this case is just going to be 8, which gives me the answer D.
The Teaching Center, UF's Learning Resource Center.